Today we are going to understand one of the most important concepts, operating system. Whether you are using a mobile phone, tablet, laptop or any other smart device, everything runs because of the operating system. Let's break it down in a very simple and practical way. So, what is an operating system? An operating system is the core software that manages hardware resources and provides services to applications. Think of it as the manager of a building. It coordinates everything to so users and programs can run work without worrying about the hardware underneath. Some examples of operating systems are Windows, most common on personal computers. Then Linux, power servers and supercomputers. Android, iOS drives billions of mobile devices. Then we will see objectives of an operating system. Think of it like a hotel manager. The OS ensures everything runs smoothly for both users and hardware. Convenience makes the system easy and intuitive to use, hiding complex hardware details from the user. Efficiency maximizes hardware utilization, CPU, memory, and devices work at their best. Ability to evolve, designed to grow and adapt, supportive new hardware and features over time. Now we will see functions of an operating system. When we run multiple apps on our phone, the OS quietly handles everything in the background, launching apps, storing files, connecting devices, and keeping our data safe. And some the functions are process management, runs and switches between programs, memory management, allocates and tracks RAM, file system management, organizes storage, device management, controls hardware peripherals, security, protects data and access. Now we will see services provided by the operating system. Like customer service at a bank, the operating system offers essential services so programs can operate without directly touching hardware. Program execution loads and runs programs. IO operations manages input and output devices. File manipulation creates, write and update files. Communication, then error detection, monitors and handles system faults. Okay, now we will see um, from batch processing to multi programming, the evolution of operating systems. Batch processing systems. Jobs are grouped and run one after another with no user interface interaction, like submitting a stack of forms and waiting for all results. Efficient for large, repetitive tasks. Slow turnaround, no feedback until done. Now, multi-programmed batch system. Multiple programs sit in memory. When one wants example for input output, the CPU switches to another. Like a chef cooking several dishes at once. Higher CPU utilization, better throughput than simple batching. अ, जैसे हम सोच सकते हैं ये सिंक्रोनाइज्ड होता है बैच प्रोसेसिंग सिस्टम और मल्टी प्रोग्राम बैच सिस्टम नॉन सिंक्रोनाइज्ड रहता है अनसिंक्रोनाइज्ड नॉन सिंक्रोनाइज्ड ओके टाइम शेयरिंग एंड सिंपल सिस्टम्स evolution of operating system. Time sharing system. The CPU rapidly switches between users, giving each a small time slice. Fast switching create the illusion that everyone is using the system simultaneously, like many people taking turns on one computer very quickly. Parallel systems. Multiple processors work together on tasks, dividing the workload like a team, splitting a big project faster and more reliable, common in scientific computing and servers. Okay, now we'll see distributed systems. Multiple independent computers are connected via a network, sharing resources and tasks seamlessly. Think of Google Docs. Multiple users edit the same document from different locations in real time. High reliability. If one fails, other continue. Resources sharing across the network scales easily by adding one more machines. Now, operating system calls and programs. What are system calls? The interface between user programs and the operating system. Programs request services rather than accessing hardware directly, like ordering at a service counter. Example: open method, read method, and write method. What are system programs? Tools that provide a working environment. File managers, compilers, and shells, like the tools in a workshop. Every in this user layer, system programs layer, system calls layer, operating system layer, and hardware layer, each layer depends on the one block. User layer depends on the system programs layer depends on the system calls layer depends on the operating system layer, and operating system layers depends on the hardware layer. Okay, now we see some conclusions of this entire presentation. The OS is the foundation of every computing system, managing hardware and enabling software to run. Efficiency and ease. It balances resources efficiency with user convenience, evolving continuously over decades. Constant evolution. From batch processing to distributed cloud systems, OS design keeps improving performance and usability. Okay, so that is it for this presentation. Thank you. Bye.